Again, David Lapp, Product Manager for Spatial with Tim Vlamis from Vlamis Software Solutions. We're going to give you an overview of what all Spatial is and what it does in the database. Tim's going to focus on a new self-service tool, give some examples of how it's used, and you'll learn how to get started. So what this is all about is analyzing information in the context of location and answering the kinds of questions that we see down below, which is obviously important because everything happens somewhere. All the information, all the people, the assets, the activities, everything that we manage in our applications happens somewhere, and Spatial lets us bring in that context. So the footprint of Spatial, before we jump right into the database, just in the broad view, spans really the whole IT infrastructure, the whole Oracle stack. So we're going to be focusing on spatial features of the database, but we do also have spatial features in the big data platform. We have mid-tier components and a set of APIs, modules, libraries that allow for all kinds of programmatic access. So Spatial really is pervasive across the IT infrastructure, but we're going to focus here on the database. And in the context of the Converged database, really just think of Spatial as one of those converged capabilities. And like all converged capabilities, it's really great because it means we don't need a specialized system for what might be thought of as a specialized sort of workload. Spatial and location-based analyses can just operate in the database and can be blended, which is a really important aspect of this, can be blended with other converged capabilities, and we'll see some of that as well. And that gives us a huge advantage, and that also allows us to just focus on the business context of the application and then let the database take care of the high performance and security sorts of features that we're able to leverage. The broad view of what we do in Spatial is, again, manage, analyze, and process all kinds of spatial and location-based information in the database. So moving around these types of data that we deal with, the most basic kinds of spatial data, points, lines, and polygons, you can think of as your customer or asset locations as points, your highways, pipelines, or lines, and your sales territories, for example, or polygons, but also a set of advanced types. Raster data, all sorts of satellite imagery and drone imagery and so forth, used for use cases like precision farming and natural resources, where we want to monitor actual ground conditions and changes over time in what we can see from above on the ground. 3D data that's used for scenarios like building essentially a digital twin of a urban landscape built environment, and do what if sort of scenario building for redevelopment. Features like linear, like routable networks, and a feature called linear referencing, just advanced techniques for managing activities that occur along linear networks. So that's obviously scenarios involving rail, utilities, highway departments, and so forth use these advanced features. And then features like location tracking, or you might have heard of geofencing, along with networking and address geocoding, for things like logistics and national security, where we're monitoring movement from one geocoded location to another, and monitoring as those moving objects move into and out of sensitive areas. So lots of different domains, lots of different use cases for these features. And another important aspect of Spatial is the fact that it's universally supported across the geospatial industry. So that it means all the commercial and open source software platforms, ETL tools, they all support our platform. So you can do all kinds of things in the database, but use all kinds of tools to operate on that data as well. The kinds of applications that use Spatial are in two broad categories, say just general business applications that need or want a location context. Put my stuff on a map, my activities, my assets, the mapping the trends of things across geographies, just your basic, show my business on a map type applications. And then specialized applications, like I was just mentioning, the kinds of tools that use some of those advanced features in logistics and transit and city modeling and so forth. So bringing it right down to the most sort of elemental view, intuitive view for database practitioners, what this means is just storing geometries, location data natively in the database in a native type with a bunch of APIs so that you can operate on it with just normal SQL like you're used to. So storing different types, spatial types, indexing them, and then asking a question like which of our customers are within distance of a hurricane path, and that query becomes just a normal SQL statement with a spatial function, SDO within distance in this particular case, that that does the proximity analysis, but there's no new language per se to learn. It's just standard SQL. So just walking through super simple example of sort of what this looks like for a database practitioner. I have on the left a table called countries, happens to have a column. The column name could be anything. I called it geometry, and the data type is this native geometry type, SDO geometry. I can select it in SQL Plus or SQL Developer like any other field and just look at it. Now this is just exposing what's inside one of these geometries, not something you generally would be using tools and so forth to create a polygon like a country, or you can download all kinds of data like this in standard formats and load it, so you don't necessarily ever go in and type what you're seeing here, but this is just exposing what it looks like, and you can just see it's a native type, and you can see the longitude latitude pairs that define this, in this case, the shape of the country of Aruba. Using it in a query, in this case I've got two tables, a table of sales regions and a table of countries, and I want to know which of my little region geometries are geographically inside the country of Belize. And so it's just, again, simple SQL query and gives me a normal result with a spatial operation behind the scenes. And we can also do these kinds of things at runtime. So I've got an arbitrary point, sort of close my eyes and throw a dart at the globe and get the longitude, latitude, and I want to know what country did that land in. So it's just another same kind of SQL statement with a contains operator, and this time I'm comparing the countries to a location that's just on the fly. You can see a geometry that I'm defining at runtime with a coordinate in it, and it gives me back a result. So why this is important is because these are the kinds of operations that can be in an application or an endpoint that accept a location to analyze at runtime on the fly. That could be based on a user clicking on a map or some type of data feed coming in from a sensor. So we can combine all the volumes of data we manage in spatial with runtime, just runtime, real-time information that we want to interrogate spatially. And there's hundreds of other packages and operators in a very vast spatial SQL and PL SQL API doing all kinds of both routine, simple things like I've shown you, but other more specialized, advanced sorts of things as well. So a huge amount of capabilities. It's also now, from the converged database perspective, important to reinforce that converged message. And JSON is one of the areas where we blend with that JSON in database converged capability. So the JSON, a feature of the database for JSON handling, the JSON value function knows what geospatial JSON is. And so if we feed that built-in JSON feature of the database a chunk of GeoJSON, we can return our native geometry. So just an example of how our converged spatial capability is seamlessly blended with the JSON converged capability in the database. And there's a bunch of other examples of that. It's particularly with respect to JSON, between us using the JSON features, our own utility functions for being able to wrap everything we do as JSON, get JSON in, spit JSON out, integration with ORDs. So JSON is one of the real great examples of that blending of converged capabilities. Want to make a quick mention about, again, the fact that we're a converged capability means we leverage the underlying horsepower of the database for security, scalability, performance, things like leveraging the sort of innate database capability for parallelizing, for high performance processing via partitioning, and for example, like local partition indexes work with spatial. So we can do all the sorts of partition pruning and stuff that you would do in general and apply spatial to that same technique, redaction and so on and so forth. And that ends up giving us a tremendous amount of scalability when it comes to both the basic and advanced sorts of features, so they can be used by national mapping agencies and multinational corporations doing all kinds of workloads with spatial that are able to harness the underlying performance capabilities of the database. Across other tools in the database, Spatial has GUIs and features in SQL Developer and Apex. Oracle Analytics Cloud and on the desktop use our libraries for their self-service mapping business apps, so transportation, logistics. Utility applications, Oracle applications use spatial and spatial features in those applications. So there's really a pervasive footprint of spatial across the Oracle set of tools and apps. And then again, from the developer perspective, I mentioned how there are the spatial features and types in the database, and then there's a set of these so-called deployable components, mid-tier components that operate against spatial. From the developer perspective, those deployable components you see across the top, they all have APIs. So mapping, I'll talk about in a moment, geocoding, et cetera, developers work with the APIs to achieve those functionalities, and then directly against the database, we provide APIs and modules to allow programmatic access via Java, Python, Node.js, REST, of course, with ORDS, and needless to say, SQL and PL SQL. So there's a really robust developer perspective to interoperating with these features as well. So quickly, from the mapping perspective, one of those deployable components, Spatial has this something called the Spatial Visualization component. So it's a J2E app and a JavaScript client for creating custom web mapping applications, lightweight applications that have rich interaction. And so there's a metadata, sort of a thick client tool for authoring those maps, the look and feel, a web-based administration console, and it's basically just a toolkit for creating custom apps. So between spatial content in the database, whether it's your content or commercial content, commercially acquired content, this spatial viz component, and the JavaScript client, you have everything you need with our stack to create a custom mapping application. That sort of developer, perspective one in a little bit of detail. The next, I want to pay special attention to ORDS, because it's so important with spatial, the interoperability of spatial with REST endpoints for mashing up and consuming spatial, both like results and integrating it into maps. So important, and JSON is like the language that these mainstream developers speak. With ORDS, as you've heard, it's really super simple to take anything we do in the database, tables and views and function results and procedures and anything, expose it as a REST endpoint. With spatial, it just is a blended converged capability. So I have a SQL statement here. Jeff mentioned that it's really easy to do this in SQL Developer, and the example I'm showing you, I did in SQL Developer to just make it easy to create the artifacts I need to create REST endpoints with ORDS. So I've got a SQL statement that's doing a spatial calculation. In this case, I've got a little segment of railway. And what this endpoint does is let me specify which segment of railway and a distance, and it'll create a buffer, a shape that's a buffer area around that segment of railway. So the scenario would be there's going to be some work done for this, maybe repairing a segment of railway, and we need to generate a buffer around it to know what land parcels it's going to affect and who needs to be notified, for example. So I just have that query, very simple SQL query with a couple of parameters, including the distance that I want to use for this buffer, and ORDS just super simple, lets me create a REST endpoint, and without doing anything else, no special treatment or handling of the fact that it's a geometry, or it just knows how to deliver that along with the rest of the data. So you can see on the right is just pulling, invoking that REST endpoint, and amongst the data in that JSON document is the geometry just automatically returned. Now, what ORDS returns for geometry by default is our JSON format for a geometry, which has a lot of, can have a lot of detail because we have very robust handling of all different types of geometry, different sorts of coordinate systems and projections and metadata that we track, and we want to provide all that in the ORDS document. There is also a sort of a simpler industry standard format for geospatial data with JSON, which is called GeoJSON. And it'd also be really nice to be able to return that so that there's no need to explain what the JSON sort of structure is to someone that's going to consume that result. And ORDS make that really easy too, because there is a way with ORDS to tell ORDS, I want the results of my query to be returned as is with no additional wrapping. And that allows me to create, in this case on the lower left, just using SQL, create the structure of this standards-based GeoJSON, inside of which I just have a spatial function that, as you might be able to see on the lower left, is using our utility function to GeoJSON, and I wrap it as I need to create the standards-based structure. And you can see on the right, I'm now invoking just a simple REST endpoint. For this example, I just had told the URI, if you put GeoJSON on the end of it, it's going to return the same result as GeoJSON. The nice thing about this is that I can structure exactly what a client needs. In particular, in this case, again, standard GeoJSON. This is a format that any client would be able to just drop in. So I just can invoke this REST endpoint from any standards-based client like the one I see on the right, and I'm going to be able to render it. So this is, I think, a real shining example of the blending of these converged capabilities. Like the sum is, it's greater than just the sum of the parts when you put these things together.
Hey, David.
Yeah.
Next version of ORDS, there'll be a application flag you can set if you want the Geo versus the Oracle.
That's
JSON.
awesome. So that's, yeah, I mean, so that's even
less code to type.
Yeah. So I think it'll always be useful to be able to do, like, this thing that full disclaimer that Jeff educated me on how to do, and so that you're always able to achieve something very tailored and specific if you need to. And then in the case like this, if it becomes like enough traction and it's important enough, yeah, I mean, it can be part of the product. So that's fantastic. That's great news. So the next one of these components that we're going to talk about is Spatial Studio. And Spatial Studio is a self-service tool for accessing the capabilities of Spatial. And we have a link in the deck here about getting started with this, because I think folks will want to play around with it. The whole point of Spatial Studio is to offer another paradigm of access to the spatial features that I've been talking about. So traditionally, it's all been about using SQL or PL SQL or one of the APIs and doing some coding, building applications to analyze, building applications to visualize. Spatial Studio is meant to provide a self-service vehicle for all that. And what it's all about is how to get data prepared, for example, address data, for example, how to get it prepared to use with Spatial, visualize it, analyze it, publish results, share results, get results into OAC for continued deeper analytic workflows. That's really what Spatial is all about. It provides this self-service UI that you're about to see, so that non-technical users or technical users that just want to sort of accelerate their spatial workflow are able to do so. And to demonstrate that, I'm going to stop sharing and turn it over to my colleague, Tim.
We're an Oracle partner. We're going to be showing some of the work that we've done with one of our clients, Outfront Media. So Outfront Media is one of the largest out-of-home advertising media companies. So they do billboards, or formerly CBS Outdoor. And what we're looking at is the interface here for Spatial Studio. And we've been doing some analysis and location analysis regarding hurricanes, because hurricanes and hurricane force winds, maybe not surprisingly, are a pretty big deal for billboard companies. The hurricanes can come through and actually blow down the billboards and destroy the structures, whereas if they take down the billboards, the structures have a better chance of withstanding the winds. So let's take a look. And what we're seeing here in Spatial Studio is just a set of projects. So these have all been built previously, and I'm going to open this one called Outfront Media Assets and Hurricane Irma. I don't know if you guys remember, Hurricane Irma was a big storm that blew through Florida back in 2017. So this was its path as it came, you know, down through the Caribbean and then up through Florida. So this is a major event for Outfront Media, and they actually lost billboards to it. And so what we have here is we have these different layers that we've imported into Spatial Studio. We're looking at the path here. We got this shape file from NOAA. So there's a very, very extensive kind of more data than you can possibly imagine available about these storms and their predicted paths. And if you've ever seen the spaghetti models and all those kinds of things available from the National Weather Service. And then here, if we click on this layer, we can see where those assets, where those billboards are and their locations and whatnot. So then obviously what we'll want to do is we have another shapefile from NOAA.
Hey, Tim, do you have your Panelists window open on the right side of the map?
Oh yeah, let me move that. Thanks.
Yep.
Yeah, thanks. You don't need to see that. Okay. So this shows the different force of the different winds. So we can see this is actually in knots per hour, greater than 54 knots. It's about, I think, 60 some odd miles per hour. So in this shaded area are the billboards that would be most affected or were most affected by this particular hurricane. And what we do with Spatial Studio is we have these different layers, we have these different shapes and positions, and then we want to understand what the interactions are. So the way we do that is we actually perform a spatial analysis. We just click on one of these and pull up the whole set of what are the different kinds of interactions that we can select and choose from in terms of, the spatial algorithms and whatnot. So we have the ability to filter. For example, we can say, return shapes that are inside another. This is one that we did with this particular analysis. This actually brings up the SDO inside SQL, and here's the document, the link to the documentation. If we go back to this and we select that, we can then choose the layers that we want to interact. As you can see, this is all, directed towards, kind of a business analyst type of person, so that we can do it without kind of code light type of development. There are a very, very large set of these SDO interactions. I'll show you a little bit later. This is actually how we built some custom territories for Outfront, because they had all these billboards all over the country, but they didn't necessarily, and they had assigned to the Chicago territory, the New York territory, etc., but they didn't have geometry definitions for those. So using the SDO functionality, we were able to define very quickly which, what is the shape of that particular territory. We can also do things like transforming things and saying, oh, if there's something inside of something else, give me that intersection. or aggregate functions and things like that. All right, as well as, you know, define how far, what is the distance, those types of calculations. So this shows these particular billboards were most affected. So these are the data sets we have here. Some of the other capabilities, we can change the appearance of these. So we have settings, so we can go in, if I wanted to change the color of the outline or those kinds of things, I can do that for this wind field, or we can actually have it based on data. Here we can see we've used 3 different shades to indicate the different force of the winds. We have a whole series of palettes we can choose. There's a lot of things that can be done with the styling to kind of design the visualization so that it, you know, you can easily understand what's going on, pull it out. We can also add various information windows so that when you click on a particular object, you can see what's its storm number, what's the radii, etc. So that when I go back and I click on this guy, I can get further information about that. And with some of these tables that have a lot of information on them, then we can actually see those columns in an interactive window and whatnot. Yeah, so let me just show you where, so this is the project interface, and this is where we do the majority of the work. We have a couple different options. We can actually drag different types of visualization objects. So if we wanted to look at the information regarding one of these particular tables from the database, we can just interact and see what the data is and whatnot. So we can actually have multiple maps, different things like that. These data sets are just defined through a connection to a particular database. And you know, a lot of times we're using now the ADW. This works really well with that. And we can see that we have all these different data sets that have been defined. Maybe I need to clean up my some of my databases as a developer, but I'm sure I'm not the only one that has a few extraneous data sets lying around in a schema somewhere. Some of the other things you can do, let me look at this guy, for example. In the properties window, here we have the connection information and whatnot, and the columns, so you can see that, and this is where we interact with the data sets so that we can, you know, prepare them. So a lot of times when you pull in, for example, these NOAA data sets, this is, we just import them from the internet. I wanted to show some of the recent analysis that we've done with the COVID-19. And here we have different layers. Let me just give you a sense of what's going on here. Let me turn some of these off. So these are the Outfront Media assets in the northeast part of the US. This is where they have billboards. And then these are those polygon sales territories that I was describing. So these were defined by doing a rubber band aggregate function and saying, okay, well, this happens to be, you know, Pennsylvania non-metro. Here's the New York territory. Here's the Philadelphia territory, et cetera, et cetera. And we can see where those billboard locations are within the territories. On the COVID-19 front, this is a data set that we pulled in from a public source that had to do with, you know, where is COVID-19 the strongest? So this is by county, and we can see that this is actually the those counties that have a high number of cases. So the light ones that are between 1 and 500 cases are pretty we kind of designed it so that they're further back, whereas the darker ones, and what we're particularly interested is those that have more than 5,000 cases. So what we've done is we've actually built a layer that shows the interaction of these Outfront Media sales territories, and we said, which of the sales territories overlap with a county with more than 5,000 cases? And so then we can start to get some insight into which of these salespeople are affected the most. And while we might say, obviously New York City is heavily impacted, but we can also see that we really don't have any assets out here in Eastern Long Island. There are no billboards out there. Not only that, but if we just did a normal database function and returned a set, they would say, oh, this Pennsylvania non-metro area is impacted. But then once we put it on the map, visually we can see it's just down in this little tiny corner where the interaction is. So, this is not as heavily impacted as some of the other territories. Likewise up here in New England. So in any case, visually showing and enabling people to see what is the, where are we going to see these impacts allows for kind of business insight. And that's really where we're headed with the interface, is to say, what can we understand? Other things I wanted to show in terms of the visualization settings, we can set the scale, we can change things. Kind of a cool feature is you can control click, you can actually rotate this. So I was going to show this with a hurricane. For example, if we wanted to look at the path and see more to the north and to the south, because that's where it was headed, we can actually rotate it and whatnot. We can, select various objects on here. So if we wanted to select these counties or clear the counties, we can just do that and then define, what are my interactions, what's happening with this particular location and whatnot. So this is a very, very easy to use, intuitive GUI, so that as you work with it, you can do things. Properties, if you're interested in seeing the SQL statement, this is just simply SQL. And if you wanted to grab this code and paste it into SQL Developer or something, this is where you'd go to get it. And it's a whole lot easier, particularly with some of these spatial functions, to just let the GUI design the SQL to start, rather than trying to count, where do I need a parenthesis, where do I need a comma, where do I need a quote mark, those kinds of things. It's a great starting point for developing your scripts. We can export these and bring them into OAC. I know there was a question on the machine learning demo before. So David, maybe you can show where we took some of the IRMA layers and actually brought them into OAC and built some dashboards. So this is just showing an example of bringing in those most impacted billboard locations. And then what we wanted to do is build some business analysis around it in terms of what's a potential revenue impact? What's a predicted revenue impact? What's the cost of sending a crew out to take down the billboard in advance of a storm and then put it back up? So you can see in this converged database environment where we're actually blending spatial analysis with predictive analytics and then bringing it back into an interface where we can do rich business intelligence type operations. We're really starting to see a convergence of the technology. So it's something that we're particularly excited about.
Thanks, Tim. I don't know if you wanted to, okay. So, and I'll just make a quick mention. I think there were a couple questions about how what are some of the mechanics around how this integrates with OAC. And at present, like, the answer today is that OAC can, we can take results, everything that we do in Studio, and we can export those results out into formats that can be readily loaded into OAC, both as a data set and as a custom map layer. For those that are familiar with mapping in OAC, you can load GeoJSON as a custom map layer and carry on your work in OAC. We are working on and planning for a feature that's going to come out in an upcoming release that's going to make it easier to directly consume analysis results that we get in Studio and just consume them with a friendly name in OAC. So when we perform analyses in Spatial Studio, behind the scenes we're creating database views, and of course in OAC you can connect to a database view and work with it. So that's doable today. But what you'll find is that the naming for those objects behind the scenes is a little cryptic, and so we're planning on features that's gonna make that handshake very, very simple, so that basically what you do in Studio can be easily consumed directly in OAC. So we're working hard and are well aware that making that easier and easier is very important to use those tools together. So just to summarize what Tim showed, what Studio provides are there's kind of four big bucket areas. There's just data in general, getting data prepared, getting data in, getting data out. There's projects like Tim showed where you visualize and analyze your data. There is this developer perspective, which is another area that we're working hard on. Currently, like Tim showed, you can access the SQL that's been generated. So really, Studio could kind of be like a SQL generator for spatial queries that you can run with and you can access through endpoints. I think there was also a question about what those endpoints provide. And yeah, it is GeoJSON, so that when you do an analysis in Spatial Studio and you grab the REST endpoint that's been created automatically for you, that's going to return GeoJSON that can just be consumed by any client that understands GeoJSON, which is like all spatial clients basically recognize that format. And then a bunch of the requisite administration type functionality that kind of goes without saying that we need to support is also there. So I want to take the last minute or two and talk about a couple of final comments. One, in terms of licensing, in line with the overall converged database strategy we have at Oracle, Spatial, along with Graph and the machine learning features, are, as of the end of last year, no longer priced options. They just are bundled with all editions of the database. And so that means additions, on-premises editions and cloud databases, which I'll talk in a little bit more detail about in a moment. But that's a huge deal, a huge factor, because it means that these really powerful capabilities that folks might think, well, should I really unpack this and understand it if we're not going to be able to license this option? And now the floodgates are open to everybody being able to take advantage of these capabilities. Specifically in terms of the Oracle Cloud databases, Spatial is part of every database, so Spatial is part of all of course, the cloud databases on Oracle's Gen 2 cloud. So here we see the cloud databases in terms of the onus of management, from purely customer managed through fully autonomous. And again, they all have Spatial, and the only little asterisks or qualifiers you see are underneath the autonomous databases, and that's for a couple specific reasons. So just DBCS, Exadata, all those cloud services, everything with Spatial is there. On autonomous, there's both shared and dedicated flavors of autonomous database. On the shared autonomous database, there are a set of features which we're including in these slides that at present are not yet enabled. And the reason that those particular advanced spatial features are not enabled is because they rely upon database features which themselves are not enabled yet in autonomous. Like we said, we leverage underlying features of the database for lots of these features. So as Autonomous enables some of the underlying requirements we have, we'll be able to be turning some of these advanced features on. And then both in shared and dedicated, what we phrase those deployable components. So so whether it's the geocoder or the spatial visualization component, all those deployable J2E pieces are not provided with or in Autonomous because we have historically delivered those components under the Oracle Home. In the Oracle database, sort of in the file system, we provide those deployable J2E files. So because the Oracle Home is not accessible on Autonomous, we are moving that delivery mechanism to the Oracle Cloud Marketplace. We've done that with Spatial Studio, and we're on the way towards doing that with the rest of those deployable components. So that's sort of just a change in how we deliver in Autonomous, how we're going to deliver all those deployable components.
Hey, David, can I add that Spatial Studio is also free? And that there is a version, I have it running on my laptop, so you can install it as a running operation. We have it running on Java Cloud Service for Vlamis, and also it's available for Marketplace. So there's several different ways to deploy it. So
yeah, thanks, Tim. It's an important point. In that very first Spatial Studio slide that I showed before Tim did his demo, there's a get started link on that slide where we cover some of what Tim was talking about, and really just all the ways of specifically accessing and getting going with Spatial Studio. But Tim, you're right. Spatial Studio, like I just mentioned, is currently today available on the Oracle Cloud Marketplace in a couple different flavors, both in terms of deployment onto WebLogic and what we call our Quick Start deployment, was just a lightweight, self-contained version of Spatial Studio running in a lightweight container we have on the Cloud Marketplace. And in that Getting Started link is also information about how you can, off of the Oracle OTN and the Software Delivery Cloud, do a local download of Studio so that you can run, like Tim was just describing, a lightweight local version. That's all in the Getting Started link that's on the slide that I showed earlier. So finally, just some resources that are hopefully useful just for the overall spatial product portal, developer guide, documentation, social media. There's a live SQL link down there about a little more than halfway down where you can just punch through and do very quickly do some live examples that are already set up and ready to run. So please take advantage of these resources. Also be aware that we have a spatial and maps series on Ask Tom with a next event coming up on the 21st. So please subscribe to that. You can check out our previous sessions and see what else we have coming up. And we also have a user community, which is really terrific. And for anyone that's interested in this and we've gotten your attention, then please take a look at this user community. Join up, and it's really it's active. It's a lot of fun and lots of great sort of sharing of information and folks helping each other. So please do take a look at that.
Awesome. Thanks, guys.